Welcome to Mitra classes. In this video we are going to discuss about the chapter alcohol, phenols and ethers, their preparation and their chemical properties. This is the chart that we are going to discuss in today's video. Reaction of primary alcohol, preparation of alcohols, phenols, preparation and reaction, ethers, preparation and reactions. So the students have already done with this chapter. For the quick revision they can refer to just these charts, so that revision can be done within 5 to 10 minutes, or else for the detailed explanation be with the video, continue the video. So in this slide we can see preparation of alcohol. So here we will prepare alcohol with ethene, this H2. Now let's start with the first reaction. Ethene with H2O, this H plus, it will get splitted in the H plus and OH minus. H plus will break this bond and OH will get attached, resulting in the formation of ethanol. These are very simple reactions, you can see. The same goes with this ethyl halide with NaOH. OH will replace X and resulting in the formation of ethanol. Ethanol is just for reference as an example. Acetaldehyde. This one H will break the bond and other H will attach with oxygen, so that CH3 CH2 OH will be formed. Now acetaldehyde with hydrogen H2, the same reaction I have already done before in the previous slide. The next is acetic acid with lithium aluminum hydride. This is the strongest reducing agent, and this reaction is a reducing agent. So acetic acid on reduction gives ethanol. First it gives acetaldehyde, then on further reduction it gives ethanol. Now acetaldehyde reacts with RMGX, that is Grignard's reagent. The other product will be propanol, but here printing mistake is there. It is a propanol because in Grignard's reagent we get one alkane of higher carbon, that is we get higher alkane. Product will be one carbon higher, more than the carbon present in the reactant by 1. So the next slide is the reactions of alcohol. CH3 CH2OH react with Na for the formation of sodium ethoxide. We also use this RONA, this is also known as RONA. We use this for the preparation of ethers too. Now when ethanol reacts with acetic acid, CH3COOH, the formation of ester is formed, that is R C double bond O O R, that is this is known as the ester product. What will happen, this OH will take this hydrogen and form water as its byproduct, and this CH3CH2 will attach with this oxygen. So in this way ethyl acetate will be formed. Now when ethanol reacts with hydrochloric acid in the presence of anhydrous zinc chloride, this is also known as a Lucas reagent. And it results in the formation of ethyl chloride. Ethyl chloride is formed. Now ethanol with PCl3 PCl5, we have already revised this reaction in the previous chapter of halogen derivatives. For PCl3 the byproduct will be H3PO3. In this reaction of alcohol with PCl3 PCl5, the byproduct is one of the important factor that plays, because students generally don't remember the byproducts, because we know the product will be definitely ethyl chloride. For PCl3 the byproduct is H3PO3, and for PCl5 the byproduct is POCl3. So let's go further. Ethanol with SOCl2, the same reaction. In this, the byproduct will be SO2 gas will released and hydrogen gas. Now reaction of ethanol with H2SO4 at 160 degrees Celsius. This temperature is important, has to be maintained for the formation of ethene. And the reaction of ethanol with Al2O3, in this also this 623 Kelvin temperature should be maintained in order to prepare ethene. And in this reaction you can see there is oxidation reaction taking place because of the strong oxidizing agent K2Cr2O7. When K2Cr2O7 oxidizes, this nascent oxygen will oxidizes this ethanol to form acetaldehyde, and in further oxidation the main product will be acetic acid. Now ethanol with copper with 573 Kelvin acetaldehyde will be formed. It is also an oxidizing agent, but a mild oxidizing agent, not a wide or strong oxidizing agent like K2Cr2O7. Now ethanol with concentrated H2SO4 at 110 degrees Celsius. See, these two reactions, the temperature factor will play very important role. At 110 degrees Celsius, the ethyl hydrogen sulfate is forming, and at 140 degrees Celsius, direct ether is getting prepared, that is diethyl ether. So these temperatures have to be taken care. Now this segment is for preparation of phenols, how phenol is prepared from various kind of substrates and reactants. The first two, three are very simple. Chlorobenzene reacting with NaOH, chlorine will replace OH and hence phenol is formed. The next is chlorobenzene react with H2O. H2O means H plus and OH minus. This OH minus will replace chlorine here. The next is benzyl sulfonic acid with NaOH. The same thing will happen and the phenol will get formed. Aniline, that is aniline reacts with NNO2 plus HCl. Aniline reacts with NNO2 and HCl at 273 to 278 Kelvin. The product that will form is phenol. In this reaction, aniline with NNO2 HCl, the intermediate product will be benzene diazonium chloride, that is benzene with above N2 and Cl minus. Then it reacts with H2 and H, and the replacement takes place and phenol will get formed. Now with cumene, let's clear the full screen. Now when it's react with cumene on the exposure in air or normal oxygen, the product will be phenol. But first it will give a intermediate as cumene hydroperoxide. This O2 will be between this O and O, something like this, and cumene hydroperoxide will be formed. Then this H plus ion will break this, and the one of the byproduct is acetone, C double bond O and C, and another product is phenol. Now reaction of phenol. When phenol reacts with bromine water, both the ortho position and one para position is occupied, resulting to the formation of 2,4,6 tribromophenol. As bromine is ortho and para directing group, in the second reaction we can see this bromine 2 is directed towards ortho and one para position, but the major product for any ortho and para directing group, the major product is always para product. The product form at para position. Now the phenol reacting at concentrated H2SO4 to give the HSO3, that is orthophenol sulfonic acid. One H from here and another H from here, and one O will form the hydrogen here, water here, and the remaining HSO3 will react. The first is already done in the previous slide, it is repeated here. Phenol with NaOH CO2, that these two are very important reactions, salicylic acid and salicylaldehyde, and they are also very famous naming reaction, that is salicylic acid is known as Kolbe's reaction. It is known as Kolbe's reaction, remember, don't get confused. And salicylaldehyde is known as Riemer-Tiemann reaction. This is the repetitive and the most important reaction. What happens here? When phenol reacts with NaOH, sodium phenoxide is formed, that is benzene or phenol you can say here, and here ONA. And when it reacts with carbon dioxide and hydrogen, the OH will get replaced here and the C double bond OH will get attached to the ortho position, resulting salicylic acid. Now when it reacts with CHCl3 and NaOH, the intermediate form is ONA along with CHCl2 at its ortho position, that is phenol, here ONA and here CHCl2. Now further it reacts with NaOH to replace this Cl, and O will be formed here, and the byproduct is NaCl here. Then further it reacts with hydrogen plus this H plus, you can see, then resulting to the formation of salicylaldehyde. So these two are the most important reactions from the phenols section, you can say. So let's continue further. Now phenols reacting with zinc. This is very basic and simple reaction. This O will come along with zinc into the formation of ZNO, and the remaining benzene is directly formed. Now phenol when react with Na2CO7, it is chromic acid, and it will result into the formation of benzoquinone, which is a diketone, and it is also a conjugated diketone because you can see the conjugation of the double bonds and the single bond in this product of benzoquinone. Now you can see preparation of ether. Now in the preparation of ether, ethanol reacts with phenol. Now what will happen is, one of the famous byproduct, this OH with this hydrogen forming water, and this phenol will attach with this O, resulting into the formation of methyl phenyl ether. In the second reaction, chlorobenzene with CH3ONa, this Na will take this Cl and form sodium chloride, and the remaining will get attached to them, this phenol and CH3O phenol, that is methyl phenyl ether. Now this is the reaction of ether. Now in the cold condition, when methyl phenyl ether reacts with hydrogen iodide under cold conditions, that is 0 degree Celsius or 273 Kelvin, the product is phenol with the byproduct methyl iodide. What is the byproduct? Methyl iodide will be formed. And when methyl phenyl ether reacts with bromine, as bromine is ortho and the para directing group, it will be attached to the para position and the ortho position, but we know the major product is the para position. Now when methyl phenyl ether reacts with CH3, this is Friedel-Crafts acylation reaction, that kind of reaction, anhydrous ALCl3 and CH2. CH3 will get attached to the ortho and the para position, and the major will be the para one. Next, the ether will react with CH, this is the same reaction repeating, CH3C double bond OCl. This is Friedel-Crafts acylation, and the previous one was Friedel-Crafts alkylation reaction. There is a small change. CH3Cl with anhydrous AlCl3 is Friedel-Crafts alkylation reaction, and CH3COCl, that is this product, with anhydrous AlCl3 is Friedel-Crafts acylation reaction, because of the acyl group present in here. The same will attach one with ortho and another with the para, and the major product will be the para position wala product. Now the methyl phenyl ether when reacts with H2SO4 or HNO3, in both the way it is the same. In H2SO4, SO2 will get attached here, and when it is reacting with nitric acid HNO3, the product will be 2 nitroanisole or 4 nitroanisole. In 4 nitroanisole, NO2 is attached at the para position, and at 2 nitroanisole the NO2 is attached at the ortho position. The major product is the ortho position. So students, this is the end of the discussion that we have started about the chapter alcohol, phenol and ethers. In this chapter we have done several reactions of alcohols, phenols and ethers, and the preparation of ether, preparation of alcohol, preparation of phenols and everything. So I hope you guys liked the video. So please like and share this video and subscribe our channel and support us and motivate us to make further videos. Thank you and have a nice day.